Hello friends. So now I am going to discuss you one very important problem on parabola, which is again based on properties only. It is mixing of 2-3 chapters, 2-3 concepts. This is truly advanced level problem. The question is, if a line x plus y is equal to 1 is tangent to a parabola at a point A, that means this line x plus y is equal to 1 touches some parabola at a point A and intersect the directrix at B and tangent at vertex at C respectively. And focus of the parabola is given 1, 2. Only tangent is given, focus is given. Then he is asking find product of AC dot BC. To understand this problem, let us make diagram of this, then we will discuss it. The given information is, suppose this is a vertex, this is the parabola, this is focus, this is any tangent at a point A, and this is directrix. Focus is 1, 2, intersect directrix at B, and this is the vertex here, tangent at vertex intersect at C. So this is the situation. You have to find product AC into BC is how much. The best way of solving this is stop the video, think about this problem, think about the properties, how you can think and solve it for some time. Equation of this line, this tangent is given x plus y is equal to 1. No other information is provided, very little information provided. Stop the video, think and solve. Now one hint I will give. We can use one property, the portion of the tangent intercepted between point of contact A and directrix subtends a right angle. That means this portion AB will subtend a right angle here at focus. Subtends a right angle at focus. The portion of the tangent intercepted between point of contact and directrix subtend a right angle at focus. This is 90 degree. As we don't know the equation of this line, I cannot find, I don't know the vertex this also, so I cannot find the point B and C also. Only I know is equation of line x plus y is equal to 1. So here one hint I will give, you can use point circle concepts you can use. So you may be wondering, sir, where is the circle? Second hint, you can use power of a point with respect to a circle. Power of a point. So this is the beauty of your imagination, and that is the beauty of maths. Because sometimes from nowhere your thoughts must come, and that is why this problem is truly IIT level problem, advanced level problem. This will expand your thinking, how to think in different directions. Okay, let us do one thing. We know reflection of S with respect to any tangent will lie on directrix. So this will be M. Reflection of S. You call S dash or M anything. And this will be same as feet of perpendicular. This will be here. And this is same as feet of perpendicular. This angle is 90 degree. Reflection of S, this length will be equal to this length. Reflection of S with respect to any tangent will lie on directrix, and if this is the focus, reflection of this will be S dash, where this AS dash is perpendicular to directrix. This again set very very important property, we will use this. But sir, still where is the circle? Okay, I am talking about some circle. Where is the circle? Can you visualize the circle? Where is the circle? So now, see the imagination. If I consider AB as diameter, then I can draw a circle with passing through S and S dash. This will be the circle. Because the circle will subtend right angle at this, in the semicircle portions, this AB diameter will subtend right angles. This is also correct now. But how to calculate AC and BC? Then there is a property in circles. This was the parabola concepts. Power of a point. Suppose this is a circle and the point is outside, or point may be inside. If point is outside, then if you have remembered this, P, this is A1, B1, A2, B2, A3, B3, A4, B4, and so on. So the product will be constant. That means PA1 into PB1 is equal to PA2 into PB2. All this will be equal into PA4 into PB4. If this is outside, this is equal to S1, PT square. They all are constant, PT square. Even point is inside. Suppose P is inside like this. Then also through this we can draw so many seconds. This can be P, A1, B1, A2, B2, A3, B3, and so on. Then also this property holds. This is known as power of a point with respect to a circle. Now in this, if you consider C as one point, then CA into CB, this must be equal to CS into CS dash, and as S dash is the reflection, so C will be the midpoint, so this is equal to CS square. This is equal to CS square. And also we know the second property, another property we have remembered. If I draw a perpendicular on any tangent from focus, then the feet of perpendicular, locus of feet of perpendicular is tangent at vertex. Again listen carefully. The locus of feet of perpendiculars dropped from focus on any tangent. The locus of feet of perpendiculars, feet of perpendicular is C, from focus on any tangent, feet of perpendicular, this is 90 degree, is tangent at vertex. That means if on any tangent I drop perpendicular from focus, they will meet at the intersection of tangent and tangent at vertex. This property again I am explaining here. What is this property? This is the focus, suppose. So from this focus S, if I drop perpendicular on this tangent, then this will meet at tangent at vertex. This point, this tangent, they will intersect at same point from where this feet of perpendicular will lie here. So this property I have to use, CS square. And this is 90 degrees. So now my question is very simple now. Just I have to find distance CS, perpendicular distance CS. So what is CS? CS is distance of x plus y is equal to 1 from S 1, 2. So that is 1 plus 2 minus 1 upon under root A square plus B square, perpendicular distance CS is equal to 1 will cancel, 2 upon under root 2 is equal to under root 2. So CS square is equal to 2. So this answer is how much? 2. So looking seemingly very difficult problem, you could solve with 1 or 2 steps if you know this property. So this is a twistor, very different type of problem. This kind of problem will give you lot of imagination power. Thank you.